All right. Hello and welcome back, all of you. I hope we are live right now. Yes, that's great. So, welcome back to this amazing platform, Pradhan Academy. I welcome into all of you this live video, and today we're going to discuss about the complex number, especially for JEE Advanced, right? So, this is a very important topic. And complex number, if you look at complex number, there had been a quite a few questions that has been asked in the JEE Advanced previous year paper. So that basically makes this topic really important. Okay, so at least you can expect one or two questions from this particular chapter. Okay, one to two questions. So definitely it's an important chapter, and sometimes it's not that way easy to start with in general in the questions. Okay, so one to two questions you can expect in general from this chapter. Now, before I start with discussing about this particular topic of JEE Advanced Previous Year paper, I would again repeat that please go through your NCRT as well as your NCRT exemplar, and once you're done with that, you can definitely start watching this particular solutions. Okay, so that is very important to understand, and then we can proceed with this today's class on discussing about the JEE Advanced complex numbers. All right, is that clear with every one of you? Okay, is that clear to all of you? Right, so let's get started on this particular job then. Okay, now before we start, again another important announcement to all of you is that we have already started live batches. Okay, so we are going to start the live batches for the upcoming JEE Advanced 202 2026 and 2027. Okay, so in case you want to enroll your for the live math classes and online batches, or you want to get a tuition directly from me, you can always enroll and contact on this particular number. Okay, you can find this number in the description box as well. Right, and along with that you can join the Telegram channel to get any upcoming contents. Okay, so you definitely join the Telegram channel. The link is in the description. Link in the description box. Okay, so in the description of this video you can find the link for the Telegram channel. Please join the Telegram channel. From the link you can find a lot of information about the upcoming classes and batches in the Telegram channel itself. Okay, so it's very important you do this. Okay, and the price is starting just at rupees 999. All right, so with this information, let's get started. So today our goal is to basically practice the previous year papers of JEE Advanced for complex numbers, and we're going to practice both MCQ types as well as numerical type questions in this today's session. Okay, so here we are. We're going to start with the very first question that is on your screen. All right, so I hope you can see the question. All right, so please give it a try. Just give it a try. Okay, so this is a question that has been taken from the previous year JEE advanced paper. Okay, so it will be quite a bit of not that very easy, straightforward. You have to apply some of your ideas, or maybe there is some trick that is involved, and that will get your question solved easily. Okay, so just think about it. It's not that difficult. Just think of it. Okay, you can easily do it. The ideas are very simple. You just have to apply the ideas of getting the roots. Okay, so if we try to solve this problem over here, first and foremost what we are going to do is that, so what we can see is that it is said that there is a polynomial f of x and is defined as x to the power 4 plus ax cube plus bx square plus c, right? And then it is said that where be a polynomial with a real coefficient such that f of 1 is equals to minus of 9. Okay, and it's also said that it is said that since this is a biquadratic equation, since it's a biquadratic, it will have four roots, and it is said that all the coefficients are real, so it definitely will have four roots. Okay, now it is said that iota root 3 is a root of the equation, is a root. So if iota root 3 is a root of this equation, then I can have f of iota root 3 equal to 0, right? If iota root 3 is the root of the solved equation, then f of iota root 3 will be equal to 0, right? And suppose this is equal to 0, okay, and this said that this is of the equation, this is another equation we have, okay. So sorry, I should have mentioned it. Let's say this is equation G, okay, where we have g of x is given as simply as 4x cube plus 3ax square plus 2bx, right? And it said that iota root 3 is the root of this equation, right? Now, now you have to basically figure it out that alpha 1, alpha 2, alpha 3 and alpha 4 are the roots of this equation f of x equal to 0, okay? So alpha i's are the roots, are the roots of the equation f of x equals to 0, okay, where I is going from 1, 2, 3 and 4. Since this equation is a biquadratic equation, it will have 4 roots. So the 4 roots are alpha 1 to alpha 4, right? Now, if we just put in back the information that is x equals to 1 over here, we are going to get this value as simply as a plus b plus c is equals to a plus b plus c will be equals to minus of 10. That's our first equation. That's the first equation, right? And also it is said that this is the root. So what we can understand that since these coefficients are real numbers, so if one of the root is iota root 3, then other root will definitely be minus of iota root 3, right? So this is something called as conjugate roots or conjugate pair of roots, okay. So definitely it's going to be like iota root 3 and then minus of iota root 3, and from here we can find it out that what will be the other root, because the sum of the root is equals to the sum of the roots is equals to minus of 3 upon 4. Oh, so sorry. The you can take x as common, so one of the root will also be equal to 0 as well, right? Very sorry. So these are the three roots of this equation g of x equals to 0, right? So if we just reduce it from, if we remove this is the root that is 0, then the equation will be 4x square plus 3ax plus 2b, that is equals to 0, right? Now from this equation you have the roots. One of the root is iota root 3 and other root is minus of iota root 3, right? So the sum of the root is equals to 0, therefore you should have the sum of the root as minus 3 upon 4, that should be equal to 0, which gives you the information that is a should be equal to 0. And once you have a equals to 0, your b will be equals to, so this will be 2b upon 4, that is equals to, so root 3 into root 3 is going to be 3, and iota into iota is going to be minus of 1, and minus is going to make it plus 3, okay. So from here you're going to get the value of b as equals to 6, right? So from there you're going to have the value of b is equals to 6, right? Now similarly, once you have a, b, therefore from this equation number 1 you can get out the value of c, that is equals to minus of 16, okay. So that is equals to minus of 16. So once you have this information, then I am very easily going to satisfy in this particular functional form, and that is going to become x to the power 4 plus 6x square plus 16, oh sorry, minus 16, right? And that is equals to 0. So I can easily factorize it out as x square plus 8 multiplied with x square minus of 2, and that is equals to 0. So from here we'll get the value of x as square root of 8 iota, right? And another root as plus or minus root 2, right? And therefore we have to basically find it out alpha 1 mod whole square plus alpha 2 mod whole square plus alpha 3 mod whole square and alpha 4 mod whole square. So if you add all the roots, all the magnitude of the roots, you're definitely going to get the answer as just equals to 20. The answer is simply going to be equal to 20, okay. So it's a very straightforward problem, very simple, easy, right? So therefore the ultimate answer to this question is going to be equal to 20. I hope this is clear to all of you. Yes, is this part clear to all of you? Hi Pranit Sarkar, hello, मैं भी IIT KGP से हूँ, basically resident हूँ. Okay, hi Pranit, it's good to hear that you're also from IIT Kharagpur as a resident. Okay, so I hope this is clear to all of you. Just let me know if this is clear or not. So if you're watching these solutions, I hope if this part is clear, we can then proceed with the next problem. Alright. So in case if you have any doubt regarding how we proceeded over here, okay, you can always question me and ask me in the live chat. And in case you are clear with this, I can definitely proceed with the next question. Okay. And if you're watching the session after the live class is over, you can always put your question in the comment section. Okay. So in the comments of the video, you can always put your question. I will try to help you with your solution over there. All right. I hope this part is clear to all of you. Right? Is this part clear? Okay. So let's proceed with the next problem then. So if this part is clear to all of you, let's move to the next problem. All right. Now this is a very interesting problem. Now these kinds of problems are very, very important, especially for mains. Okay. And sometimes in advance also, these questions are also asked. Okay. Right. And this is a question that I've taken up from the JEE Advanced 2023 paper. Okay. So it's also an interesting problem that has been asked in the paper of 2023. Let's see how we have to proceed this. So please try to solve this problem. So first and foremost thing that you look on over here at the first problem is that it is said that A basically contains a set of positive integers n, and it only contains only one integer, that is the cardinality of the set A is basically given as 1. The set A is given such that it is a complex number of this particular form. Okay, such that your theta belongs to the real number and it only contains only one positive integer. Okay, and A has one positive integer. So when it is mentioned that it is having positive integer, that basically means that any number which is present in the set A will have the imaginary part equal to 0. So any number present in the set A will have the imaginary part equal to 0. That's the first and important thing that you need to understand over here, right? So once we understand this particular part, then it is much simpler in our job is that let us take that particular number that is and we try to simplify it off. So if I take 281 as common, then this is going to be 7 plus 6 iota sine theta whole divided by 7 minus 3 iota cos theta, right? Now if I rationalize it, or I should multiply with conjugate because division with a complex number is not possible, so we have to just simplify it out by using the idea of conjugate multiplication. And if I do that, it is going to turn out as 281 times 49 minus 18 sine theta cos theta plus iota times of 21 cos theta plus 42 times sine theta over here, right? And then whole divided by is going to be 49 plus 9 times cos square theta, right? That's what you're going to have. Now it said that the imaginary part should be equal to 0. The imaginary part should be equals to 0, which makes this part which is present with the iota should be equal to 0. So if I just equate it to 0, what you're going to get is interesting is that if you just divide it by 0, you'll get an important answer, that is tan theta is equals to minus of half. So if tan theta is minus of half, and by using the half angle formula, So I can find that our sine to theta, that is going to be equals to minus of 4 upon 5, and cos to theta, that is going to be equal to 4 upon 5, right? So once we have this information, then the real part of A is equals to 281 times 49 minus 9 times of sine of 2 theta divided by 49 plus 9 times of cos square theta. Okay, I just made a one mistake over here. It should be cos square theta. It should be cos square theta over here. Okay, it should be cos square theta over here, which is equals to 4 upon 5. I hope this part is clear, right? So once we substitute back into this information over here, the real part is going to come out as 281 times 49 minus 9 minus multiplied with minus of 4 upon 5 whole divided by 49 plus 9 times of 4 upon 5, and that will give you an integer value that is equals to 281. Okay, so this is going to come out as this part, and this part is going to cancel out, and the integer value is going to come out as 281, which is the only positive integer. Okay, so I hope this part is clear to all of you. Is this part clear to all of you? Yes, no, anything? Please let me know if this part is clear or not. Please give me a thumbs up if this part is clear. If this part is clear to all of you, please give me a thumbs up. So I hope this solution is clear to all of you. Okay, just try to follow the steps that I am doing over here, and if you do the same steps in the exam also, then this sync questions are going to be very simpler and easier to you. Okay, just mind the steps and everything is clear. I hope this part is clear to all of you. Please let me know if you have any questions. I'm basically going through a live chat. Okay, please let me know. And in case this part is clear to all of you, we can proceed with the next problem then. In case the solution is clear, we can proceed with the next problem. Okay, so I hope we were able to solve this question, and the answer of this value of n is going to be equal to 281. Okay, so that is the n value. Okay, 281. So are you all getting the answer as 281? Okay, that's good. So with this, let's move to the next problem. The next problem is again kind of a similar problem, but here it is directly given as a complex number with non-zero imaginary part, right? And from there you have to basically figure it out what's the value of magnitude of z whole square of it, right? So again, quite a very similar. What again in this types of question, what is generally suggested is that try to assume z as some arbitrary complex number as x plus iota y, right? So if you just try to assume it like this way, and then there is an important property that is mod of z, then we have a property that is mod of z whole square is given as z into z bar. Okay, so this is a very important property, and if we will try to use this property over here, right? So let's see how we do it. And it is said that in this complex number, the non-imaginary part, okay, or the complex part is non-zero. All right, but if you try to observe over here is that for a complex number, and its conjugate will be given as x minus iota y. Okay, x minus iota y. Now, if I have to make z as purely real, okay, as purely real, because this is a complex number with non-zero imaginary part, right? If the I have to make this z as a purely complex number, then z is equal to y is equals to 0, right? For purely real, part, y should be equal to 0, right? Now, when y is equals to 0, if y is equal to 0 and I'm putting back into this equation, z and z bar are equal, and in that case also I will get w, and let us consider this is w. Let us consider this complex number as w. So in that case, I will be able to get w is equal to w bar. W is equal to w bar, which basically gives me the information that this is a purely real number 2. Okay, so this gives me the information that it is a purely real number 2. So what I'm doing is that 2 plus 3z plus 4z square whole divided by 2 minus 3z plus 4z square is equals to the conjugate of the same thing, that is basically 2 plus 3z bar plus 4 times of z bar whole square, and then this is going to be 2 minus 3z bar plus 4 times of z bar whole square of it, right? So if I just simplify it, if I just cross multiply on both the side, okay, so if I just cross multiply both the side, you're going to get a very big expression, and that expression is as follows, that is 4 minus 6z bar plus 8 times of z bar whole square plus 6z minus 9 times of z bar plus 12 times of z into z bar whole square plus 8 times z bar whole square minus 12 times z squared z bar, and then you will be having plus of 16 z square z bar whole square, and that is equals to 4 plus 6z bar plus you will be having 8 times of mod of z bar, z bar whole square minus 6z minus 9 z bar, and then you have minus 12z z bar whole square, okay, and then you will have 12z square z bar plus 16 z square z bar square, right? So this is all the information that we will have, and if you just cancel the common terms, so this term will cancel out. Okay, so if you just try to simplify this expression, it's going to simplify and come it out as 12 times of z minus z bar plus 24 times of z bar minus z multiplied with z bar should be equal to 0. And if you do that simplification further, it is 12 times of z minus z bar is given multiplied with 1 minus 2 times of z bar is equals to 0. So if I just put it back, okay, so again, if I generally put the expression that is z is equal to x plus iota y over here, in that case I will get the solution as 12 times of, so x z minus z bar will give you the solution as iota y, right? And then it will be 1 minus 2 times of mod of z whole square, that is equal to 0. So from this equation you will have either y is equal to 0, or you will have 1 minus 2 times of x square plus y square is equal to 0, right? So since y cannot be equal to 0, this is not possible. So the only possible way is this, right? So therefore we will have mod of z whole square. So from this part, over here we will have mod of z whole square is going to be equals to is going to be equal to 1 upon 5, 1 upon 2, or that is 0.5. So therefore, in the question it is asked about mod of z square. So that is going to be equal to simply about 0.5. That's the correct answer. Okay, so 0.5 is going to be the correct answer over here. I hope this is clear to all of you. I hope this solution is clear to all of you. please do let me know if this is clear or not. Just let me know if this part is clear or not. Okay, so I hope this solution is clear to all of you. So just do the algebra, and if you simplify this part, the solution is very, very simple. Just carry out the algebra on your, and solution is going to be very, very simple. All right. In case you have a doubt, please do let me know. Is this part clear to all of you? All right. So let's move to the next problem then. So the next problem is talking about another very interesting problem. It said that z bar denotes the conjugate of a complex number z, and iota is denoted by I. And in the set of complex numbers, the number of distinct roots of the equation that is mentioned over here. So if you look at this equation, the equation that is mentioned to us is z bar minus z square is equals to iota times of z bar plus z square. So if we assume z as x plus iota y, and if we try to carry on this algebra over here, we'll get this as follows: x minus iota y minus as over here, so now if we carry the algebra over here, right? So I hope this part is clear, the solution, right? So what I'm going to do is that now once we are able to clear this algebra over here, I'm clubbing the real part and the imaginary part differently. Okay, so that we can compare the real part and the imaginary part, and from the real part and the imaginary part comparison, we'll come out with the common solution over here, right? So on comparing the imaginary and the real part with the real part and imaginary part with the imaginary part, so I will get some kind of similar solution, and the equation as follows. So I will get the equation. Okay, this is the first equation, and similarly the second equation will be like x plus x square minus y square is equals to minus y square plus y plus of 2xy is equals to 0. That's our second equation, right? So if we just have these two equation and if we just add the equation 1 and equation 2, from here we will get 2x plus 4xy is equals to 0, and this will give me the solution as 2x times 1 plus 2y is equals to 0, which basically brings me the case either x is 0 or y is equal to minus of 1 upon 2, right? So on solution, we will get this kind of solution. So if I have one case where x equals to 0 and I put it back into this equation, so if I take this case when my x is equal to 0 and I put it back into this equation, I will get y either is equal to 0 or either 1. So that will give me the complex number either 0 or either an iota. And if I put y is equal to minus of half, in that case I will get x values equals to, in that case x values will be equals to plus or minus root 3 by 2, plus or minus root 3 by 2, and which basically gives me the complex number as root 3 by 2 iota, root 3 by 2 plus minus of iota by 2 and minus of root 3 by 2 minus iota by 2, right? So therefore we have total of four distinct complex numbers. Okay, so therefore we will have total of four distinct roots. Okay, four distinct roots over here. All right, so number of distinct roots of the equation is going to be equal to 4. I hope this part of the solution is clear to all of you. All right, so this was all about the important numerical type questions, especially for the chapter of complex number. Okay, for the upcoming JEE Advanced paper. I hope the solution is clear to all of you. Please do let me know if you have any questions. So what I'm doing is that in general, in whenever you solve any questions or complex number, whenever anything is not mentioned about the complex number z, it is always advised to you to start the complex number by assumption as taking z as equals to x plus iota y. Okay, so if you take that assumption and then you carry out the algebra and then you compare the real part with the real part and the imaginary part with the imaginary part, the solution is much simpler. Okay, so please try to follow this advice and the steps that I am proceeding over here. If you do the same thing, you're definitely going to get the answer in a very easy manner. Okay, so make sure you do that and follow the steps. Okay, so with this I come to the end of today's session of discussing the important numerical type question, and we will come again live and where we're going to discuss another important topics about the MCQ questions, and also we're going to discuss the other important chapters, especially for the upcoming JEE Advanced examination. So with this, I wrap up